So, hello everyone, I would like to welcome you in this third lecture of the course called Production Digitalization. My name is Kashif Mahmood and I am working here as a researcher and also I am one of the teacher of this course. I think Vladimir already introduced who are the teachers, and I think last time I visited briefly in the start of the lecture. About myself, yeah, I'm working in this Department of Mechanical and Industrial Engineering. Actually, I'm also a graduate, or I'm graduated from this university also, of course, but in the program called Industrial Engineering and Management. Few years ago, maybe more years ago, few more. Because then I started my PhD, so PhD I even finished 3 years ago in production engineering, and then I start working here as a researcher like Theodor, Estigeles Theodor. But we need to do also teaching, and we are a part of this research group led by Tauno Otto, professor, smart manufacturing. So yeah, in today's lecture, I will go through, as it's about the digitalization and it's a production digitalization, so we will touch or we will go through one digital tool. It's called visual components, and then we will move forward. In the first part, basic thing, and then maybe little bit advanced one. But for that, I first also would like to do some recap. I think Vladimir already shown, he already, I think, went through or shown you this kind of diagram of the digitalization, and I think he went through quite much theoretical background of production digitalization and so on and so forth. So I think you are aware of. However, still this kind of transformation of digitalization in the production is started perhaps quite a long way before. However, since we are working in the digitalization or digital twin, so what we're going to do in this course, let's say, and or how we can see, let's say, the digital twin itself. So you see the digitalization is in the horizontal axis right now here, and then we have some phases coming up, that how the things are developing and what are the technological developments are there. So at least we gonna cover first stage. So definitely we gonna create some kind of digital mock-ups of a physical plant. Okay, definitely we don't have a real case right now, but in the end, as you have a group work, so if you are working in some company and if you have some real use case, then we will, or we encourage you to do this kind of digital mock-up of your, let's say, real production systems, or let's say the production line and so on. So that we definitely try to do it. And then the second stage here we have where we have data analytics, IoT sensor, and so analytics we will do it a bit. We will create some dashboards to analyze the production systems in the virtual environment, like what we're going to create, what we're going to simulate of the digital mock-up, the layout design, simulation, and then analysis we will do. That we will cover also during our, let's say, group work, and also the tools we using helps you to do that kind of some statistics or some kind of analysis of a production system in the virtual environment again. And then there are other things which have different kind of, let's say, the building blocks of Industry 4.0, which we are not directly, let's say, address in this course, but it's kind of quite things that are in development phase right now. Still research works are going on and so on and so forth. But for the digitalization, so I think digital tools, as you are using, I think, in your daily life and other, so from paper to some digital tools that help you to do your daily task. If you're doing, again, everyone use it, some kind of documentation, budgeting or whatever. So you use Excel sheets, and then from there we are using even some ERP software, which are enterprise resource planning software, and some simulation tools also, or some process mapping tools and so on. So digitalization in production also move in this way, that you use at least some digital tools to address specific problems. So for that purpose, we're going to use one of the software. Is a commercial software. It's called Visual Components. And what it is 3D manufacturing simulation software. And as it said, that simple, visual, powerful tool for production simulation. So we're going to create it their production layouts and simulate them, design and validate the new production solution, support for critical planning and decision making process. So the idea of the simulation is, if you're going to ramp up some new production line, or if you would like to change something in the existing one, so the idea is to ramp up or construct or create those things in the virtual environment, validate it, let's say check the feasibility, and then implement it. So that's the idea there. So it's usually save your, let's say, time, and also give you a good planning, good decision making, so that after implementation you don't need to do, let's say, more changes. Because if you do frequent changes in your production or in any manufacturing environment, it costs you, let's say, kill your time also, or you just, let's say, like spend spend more kind of resources to do the things. So the validation of the idea for the production, let's say I would like to automate something, manual thing is going on, I would like to have some cobot for the implementation. How does it work? How the layout design look like, or is it really good enough to fulfill my demand, like the throughputs and other. So such kind of KPIs, key performance indicator, we can touch also, so that in the end we can make some decision. Okay, is it good or not good? One robot is enough, two robots are enough. It is good investment that give us some payback after some years and so on. So such kind of analysis we could do it in the virtual environment. 3D is good to have because it's immersive, more to the point, and you can even see some critical movements of, let's say, the robot, if I'm talking about. So there are a couple of examples here. I think from the visual component. So yeah, this I think Vladimir perhaps showed you last time, this simulation or not. This is one of the basic one. Let's say it's created in the visual components. So we can have some conveyor line. There is, let's say, machine tending going on. Cobot is there, pick and place. The task for the robots, actually, usually in the companies, either they do pick and place, or okay, now used for welding purpose, loading and unloading thing. And then there is, let's say, we put some inspection also, and if the things are okay, it goes there. If not, it becomes, let's say, in the red color. But here we also collecting some data and making in the flag, like how many parts into the system, which can help us to find out what is work in process. And also machining time is visible. Parts produced after machining, the one that are in this conveyor, means that these parts are produced, and if something is rejected, then it can show. So it kind of like, say, the digital info panel there also in the virtual environment, which can be used for in the real environment also. Right now there are I think also quite many companies providing this solution of monitoring of your production with the help of KPIs. So there are solutions are available. So such kind of mimic or the simulation we can do it into the virtual environment with the help of visual components. So this is just, let's say, the robot cell, or again something that is do with one robot and couple of conveyors and the machine is there. Robotic cell in the virtual environment. The things can be created that detailed also in this visual components where we have walls. Another is also one of the project we did it. So here this person is taking some kind of products. Actually, it is one of the use case that we work on with the company called Culinaria. It's like a food production company, the one who provided ready-made food to Selvar. Selvar, everyone knows Selvar, yes. So they have too many boxes, transportation of too many boxes. So idea here to check this mobile robots implementation. So usually they have a manual kind of boxes, transportation of these red boxes, and we try to simulate it or plan the routings of the mobile robot, and then the robot, let's say, deliver the boxes at the right place at the right time, because they have some planning issue that there are different spots or intermediate buffer in the production area where they need these red boxes, and so they don't know when and where needed. So with the robot also, with the path planning and, let's say, connectivity with the sensor also could work better, so that the robot can go and pick the boxes and just deliver to the, let's say, the production area over there. So such kind of, let's say, analysis or study we also did it, but here the things are, we ramp up the line or the, let's say, the factory floor on the floor plan. The layout plan, we got it from the company, let's say, and it was AutoCAD drawing file for the floor plan, and we tried to put the things over there. But the idea here just to focus on this, let's say, the mobile robot movement. So it's the case for material handling in the production, or we can say that production intralogistics, that how it can be done. So I mean, the idea can be that detailed also, but anyway, it takes time, and also let's say the expertise. If you do more customization, then you need to know the software itself also quite well. So this is a couple of example. We will move to the, so you see that we just try to here execute something connected with, let's say, salad packing. There was, anyway, salad 3D models were not available, so there are some kind of things that you can see look like some product, the idea again, then how much time it takes to fill this box, then when robot should come to pick this box, these things we try to figure it out through this simulation modeling and simulation model. Then let's move it to the visual components again, that what it is and how it's connected with the Industry 4.0. So as I think in the previous lectures, Vladimir covers something with the Industry 4.0, even 5.0, but Industry 4.0 have these technological pillars, so how the visual components address those pillars. So as it mentioned, visual component helps to execute Industry 4.0 related to the technological development such as advanced simulation, digital twin development, virtual and augmented reality, and so on. So they have, okay, first thing, advanced simulation, and again, if you would like to develop the digital twin, you need to first come up with the digital model or digital mock-up, which we can address through visual components for sure. So that is one thing, because the digital twin itself have other, let's say, attributes that it should communicate. The virtual and the physical world should have some communication, the feedback system and so on, but here we do, let's say, offline, not in the real time. But again, for the digital twin also, first stage, you must have the simulation model, let's say, on the 1-to-1 scale. Then in the visual components, we can do some kind of, actually it's possible to use the virtual reality there, because they have also one very good, not the plug-in, but application called visual component experience. It's a visual components itself, but there is a application freely available, visual component experience, which is not that much. I think you don't need any license for that. You can download and use it. However, what can be connected there, you must create it into the visual component. So whatever we're going to create it, if you have the headset, VR headset, another, you can be in that environment and visualize it. So we even can try it. We have this our demo center, where we have quite many. Not if there are not many, then there will be many. Some headset for the to, let's say, see this immersive visualization through VR headset, let's say. So virtual reality, it's like embedded there in the visual components. But anyway, virtual reality, augmented reality, it's in the following lectures. Somebody will cover more in detail. Performance calculation, let's say some analytics thing is also possible. We can create the digital dashboard. So whatever we're going to create it, we're going to analyze it. Let's say some KPIs, if you know about what are the manufacturing KPIs, like the key performance indicator. Based on that, we make some decision or analyze our, let's say, system, or let's say see the health of our system. So if I would like to see, okay, simple is the throughput, how much I'm producing per hour for my production system, we can even do this kind of analysis based on what input parameters I'm providing. So for the simulation, definitely it's an input process output thing. You must have some input parameters. There is some calculation going on, and then you have the output. This is advanced in that way with the visualization and in 3D. So simulation can be in 2D. So the one who use Arena, perhaps they coming up with the 3D version also, because everyone is competing in this commercial software world. Technomatic, Siemens, you use it, plant simulation. So this is also one of the player there. So again, visual components, we're going to use it as a digital tool. It can be any other 3D simulation software also that can be connected with this course or this kind of, let's say, this study. So, but we found it more interesting, this, so we are using. And the virtual commissioning and this validation, so they have some plugin, so we can even connect our, let's say, PLC to the virtual environment and simulate those also. So again, the validation before, let's say, implementation in the physical world, we would like to validate our idea, feasibility of, let's say, some new things, some changes in the production or in a production cell or in any other environment, since their course is productions or manufacturing digitalization. So we focus on that area. So that's why I'm talking in that way. Why manufacturing simulation? I think, again, this the things that are also went through by Vladimir, I hope. So there are a few benefits that why we're doing it and for what is the purpose. So to design some good solution, a smarter solution, again, before going to the real implementation, then to predict the performance, then how much I can produce, what capacity I have it. If I have virtual model ready, I run the simulation and say, okay, I can produce in 1 month that amount. Design concept, again, layout design and so on. So we can do different scenarios of the layout designing in our floor plan, or let's say in the production floor, that we can also speed up with this with the 3D simulation. And also, yeah, it can be like if you have project proposal to introduce to the tenders and to other people, let's say, so virtual environment always good to have it, and it makes better understanding for everyone. To validate the changes virtually, as I said already, and also return on investment could be improved in the sense that you know better when I invest something and when I have like profit after this break-even point. So business case also can be discussed or can be, let's say, addressed in this through 3D simulation. Again, based on some analysis of the KPIs, you have some numbers there. From there you can convert the number to the business KPIs, let's say. Okay, let's move further through how the visual components is working. So you have at front of you these computers. Yes, it has visual components. So I just say that visual components 4.8, please just start run there. It takes time. It's a little bit heavy software. Sometimes it takes a few minutes, maybe sometime not. Actually, yesterday I already checked it. So I think it's working. You just started because it takes time. There are quite many 3D models. So 3,000 3D models are there. So library takes time to populate. So that's why. But yeah. So in the visual components is a basic workflow that how we're going to work over there. So we have something there where we call e-catalog, or where we have CAD models. So there are quite many 3D models, CAD models are available for different manufacturer, different machines, robots, and so on facilities. So we starting from there. After we found out, okay, if I need to create, let's say, the production cell, then what components I needed. If I found those components in the, let's say, in the this e-catalog or this CAD model library, then I start creating the layout. So we just putting logically our components so that we execute a whole process. So the second step is to, let's say, layout planning, configuration, and simulation. And as I say that after we have this simulation ready, we can transfer it or make the mirror of this 3D simulation in the virtual environment. So you can be in that environment with the headset of virtual reality. And then it can be shared also through PDF and so on. So sharing is caring, and it's always best to show your work with the others also, that if something important to show. So this is like first three steps are, or first two are the main one that we do it. So it looks quite straightforward and easy, I think. Yeah, we'll see. Okay, now in the following slides, I have a really basic of visual components, like how the user interface look like and how you can scroll with your mouse buttons. So yeah. Okay, I will, if somebody has problem, there is IP address also. I think 1, 2, 3, 4, 5, 4, I think computer perhaps have something. I hope others are okay. I couldn't manage there actually yesterday, but I will provide you this IP address. You need to put this floating license we have and so on. Don't worry. I just would like to cover a few slides and then we move to the visual components together. Okay, so visual components, who didn't use it before, so it's like the user interface look like it's nothing something I think out of the blue. It has 3D view selector, 3D world. So if I say let's drag something in the 3D world, so you know that this is a 3D world. And then e-catalog is here, where we have different models. There are different other tabs, and bars or control panel is a simulation control where we can run the simulation, and here is the dock panel where we can find some properties of the component. Whatever component you want to drag it into the 3D world, the property is visible here. Again, I said that this even basic, but I just would like to cover those things in the slide so that when you open it, you don't be surprised. Okay, next is better that we start working already with some robot dragging and start moving the joints and so on, so that you familiar with the mouse. Actually, mouse is quite needed with the laptop, but this touchpad perhaps is not that comfortable. So how you can rotate, how you can move it, how you can zoom in, zoom out. So those things, if you already familiar, then, or if you get familiar faster, it's easy to create the things and move around there in this visual components, because it's again big 3D environment. So if you more components you have, better if you have very good grip on everything with the buttons and especially the mouse buttons, what they are capable of. This we have visualization. So there are different views. Another 3D view selector is the same as in any other CAD software. So we can just pass by those slides. There are different tabs, and let's say the user interface have different kind of toolbars, dock panel, simulation control I talk about, but mainly we will work on home tab, and the most important is process tab. Since this is not the programming class, although the backend is in Python of this software, so we will not touch this programming tab. Modeling also not on that level, because we are not designing some CAD models there. We are going to use the models that are already available in this e-catalog. So mainly we work in the home tab and the process tab. So these are of course file, you need to save it, yes, so that we want to use it. What else we have? In home tab, some other things we will see when we go through with the basic exercises. Good to know, copy paste is the same, control C, control V, okay. And selections are, we usually work on mostly in PNP, plug and play, that have more, how does it work. Whatever you will have in this 3D world, it populating in this graph cell, which is next to the e-catalog. So if you miss something where it is some small component, so you can go through this graph cell and figure it out also. Coordinate system, nothing out of the blue, X, Y, Z, linear, and the rotational is angular one also. That we work on, but since we perhaps don't have some exact kind of plan where to put in what distances, so we are just randomly putting the things. So, but anyway, it has this coordinate system where you can be more precise with the things. Okay, this we will do it together, some movements of the robot, because robot is one of the main player that we're going to use it during our exercises. So that kind of first thing we usually do with the visual components, to have a robot and move its joints and see how does it work. The other thing is PNP is a plug and play tool, which is one of the important thing. If I need to connect one conveyor to another, or if I want to connect one component to another, I work with this PNP was the PNP tool, and that's work just you need to bring the things together, and we'll see. But I mean, it's more comes up when we do by hand those things. So you plug and play. Sorry, I forgot this. So yeah, plug and play is the tool that the command that we will use it. Something else connected with the exercises. So in the process tab, there are those main three things that we need to deal with. One is the product type, so we must define the product. The other thing, process flow, which is this flow, how the simulation works, so we'll see. Second is the processes. Processes is flow is the one that how the things, the sequence of the activities. The process is like pick and place, machining process, transportation process. So these are the processes. We will see that what components can do. So that we need to connect through flow. That we also figure it out. So how it is look like is more about also by if you miss something or you would like to know that what there. I mean the slides are also somehow help you later on. But for me, it's important that we go through the things together and you understand by yourself. Later on, you can go through the slide by yourself also. So, and then you understand that what you did it also in the slide is there. Some other nomenclature, it means some kind of vocabulary that what is process node, what is process tab, and other thing. It's here. So link human robot controller, human transport controller, what is called in the visual components, we'll see. But they are here also, and numbering with them 1, 2, 3, 4, and how they call in the visual component is the list is here. Okay, we go through the exercises, and first of all, I want to fix the issue of the access of the visual component for those who don't have. But okay, and then I open this slides also in the Moodle so that you can also look through. Okay, for those who already have the visual components at front of you, then I think this is the environment. Just perhaps you go to the models by type, then you go to the robots. There are quite many. Perhaps let's go to the visual components one, which is somehow in the end visual components. And then in the visual components, let's try to have this generic articulated robot. Nice to see the color has changed. Okay, because it's already again the history of this software that we are using for, let's say, 2 or 3 years, and maybe more, but it's updating quite fast. So we started with, I don't know, 4.2, and now we're using 4.8. So quite much development, and it's really hard to catch up that what updates are there. They are too fast with the things. Anyway, this robot, if you have it, or maybe any other, just try to move it, press it like a left mouse button and select and see that what you can move, and then if you press both mouse button, then you can move the 3D world. And I'm working in PNP, then you can, if you go to the move, then visible is the coordinate system, then you can move and see that in which direction you can move. Also, with the interaction, you can go through and just move the joint. So if I have this interact, and if I move it, so in this way I can move the robot also. So such exercise you can do it by yourself or just try to get familiar. Meanwhile, oh sorry, if there is a marker then I need to write this IP address. So who cannot access? 4 of you. So what is asking some? Yeah, okay. So his marker is very good. It's not working. Okay, then something. No. So 192, if I remember, 40, then 245.59. So this is, if you put it, and you need to select this, my organization a floating, and the first field, if you put this address, I hope it would work. Is it? Really? Maybe I missed something. Okay. Then it's 193. Okay. So with this address, the one who cannot get in, I think, hopefully able to get in the visual components. So then it takes some time to load this 3D models. I don't know how it works, but I hope perhaps you need to do some restarting and so on. Let's see, but at least you get in. Okay, so with this robot, and if we see this slide, so the slide that we have it, those things we can try it. So with the left mouse button, and if you select the robot in the PNP, and then you can see that how you can move it with interact. But with the PNP, we usually work and try to move and see that what magic is happening over there. Yeah. Sorry?
Can you repeat the process for getting that robot?
So, yeah, say it again.
How you basically got this robot? It's from this.
Yeah, it's from e-catalog. If you go to this e-catalog here, I mean, for you, perhaps it takes time to load this 3D models. If you go to models by type, and then you go to robots here.
Is it Unity or Unity Hall?
It's visual components. It's even not Unity.
I mean, where to connect what program to start?
Yeah, it's a visual components.
Visual components.
Yes. How many models you have here?
So I have all models, public models, my models.
You need to do some restart actually. restart, close it and open it again. Then there are models coming up, loading of the model. So, or one thing that you can do some refresh, but usually it's not working. So if you click over here, models by type, and you see it's still loading, and then the models is here popped up, and in the end you see the items. So I have 3,160 items in models by type. So it means if there are, then you have all the things. Otherwise, you can right click over here and refresh models by type also. So sometime it helps also. But better to close it, the software, and open it again. Actually, but others are okay with the software, yeah. Because these few computer, I couldn't manage to log in yesterday to open, because we just updated to the 4.8 visual components, and visual components 4.8 a few weeks ago installed here in this computer class. After installation, it should be open like 2-3 times to have all the models uploaded. So yeah, that's why maybe some of you have some problems. Okay, then we can move further with some exercises. So what we're going to do, we're going to do some machine tending exercises first of all. So there are a couple of them. Although both are machine tending, like there are robot, we will use it for loading and unloading the machine. So which we call, let's say, automated one, so robotic one, and then we try to use a human dummy there, which we call, let's say, manual one, and try to simulate it. So the idea, some inputs coming from the feeder, robots pick and place it into the machine. There are some processing of, let's say, if it is turning machine or milling machine, whatever we're going to use it, let's say turning machine, after processing time, the robot pick it out and place it to the another conveyor, and that's it. So this is the first one we're going to do it, and the next one is we replace this robot with, let's say, some human dummy. So it means that the worker is doing this loading and unloading thing. You can we will start in this way, that where first of all we need to find the 3D models or the components. So e-catalog, where we can find conveyors, everything in the conveyors go with the visual components, go in the visual components and drag couple of conveyor there, find machine also, and the flow components for the connection that I will show, and so on. That is, and what components are needed and where you can find it. So in the slides we have two straight conveyors, product feeder, where you can find the product feeder, it's in the PM flow component. So in e-catalog PM flow components you can find the feeder there, and then we need some, let's say, sensors, or let's say flow component that trigger the robot to pick and place, to conveyor process, from conveyor process also from flow components. Then we can have, let's say, parametric 5-axis lathe machine, which is we can find in machines, visual components, e-catalog models by type, and robot controller, PM transport controller, robot, that we use it, it's in the generic articulated robot visual components, you can find it, and the gripper also. Just try to do it, otherwise definitely we will go through together. And then we need to create the flow. The next thing is to create the flow, and how it's going to be, that we also can look through it. And then we simulate it and run the simulation, let's say, for at least 1 minute or few seconds, whatever, and just to see the process is working logically or not. So that we'll see. The next thing we gonna do, we remove the robot with by the human worker. So before it, robot doing the loading and unloading. Now in the second exercise, let's say the human worker will do it, and we'll see that how we can connect those things. Again, in the slide, what components are needed, where you can find it also highlighted here, and then the connections, how you make the flow. And here is one more thing that we need to connect the interface also with the controller of a human worker. So such kind of thing we will do it. First of all, also I would like to make these slides available for you in Moodle, so that you can also parallelly can look through it. Yeah, I make these slides available on Moodle so that you can, yeah. Then you can go through by yourself. Okay, then I'm removing this guy or robot from there, and we go through the first exercise together also. Any question before? I think the visual components is up and running for everyone. Is okay?
How do I get to the Moodle?
Good question. Who can answer this? Or who would like to answer? I mean, I'm asking. I hope your classmates are there. Yeah.
The question or which module is it?
What?
Like which course is it or the password or
Force and password currently.
course is production digitalization.
Ja, Moodle zien. Production this one.
Yeah.
And what's password?
What's the password?
I haven't.
First 2 lectures by another teacher, so I see this is my first time. Digital Magic 2024.
I think so.
But I need something in caps lock, another. Please send.
Yeah.
Or so you are first time in this class, or?
No, second time.
So you, okay. So you didn't know the, okay, so it can happen, yeah. It's actually, yeah.
Digital Magic with capital D and capital M.
Digital Magic
2024.
2024 altogether, D is capital and MM is capital, yes. We have a success, so good. Okay, then let's start with the first exercise, then we go through step by step. So first exercise, as I said, that it's about this machine tending, where we have feeder, conveyors, all the components that are marked in this slide. So we will use those components, and how we start with models by type we have. So first, let's say we could have PM flow components, e-catalog models by type, PM flow components, visual components, and this feeder I just drag it into the 3D world. Computer is so slow, no? Okay, okay, it's working. So now I have this feeder over here, and if I play the simulation button here, press it, so you see it's giving some cylindrical shape puking out or giving out. So that is the first thing that you should have. Next thing, we need some conveyors. So we go to conveyors, and again visual components. Let's drag a couple of them in the 3D world. And then now is the connection. So I would like to connect this feeder to this conveyor so that the cylindrical part roll over the conveyor. So for that purpose, we must be in the PNP first, and then we bring this feeder, let's say, closer to the conveyor, or conveyor vice versa, conveyor closer to the feeder, and then see this green arrow appears with the left mouse button. I press it and bring it closer and just snap it or plug in there and release button, and then if it's become light green, it means that it is connected. If it's still yellow, it means not. If it's connected, it means that if I press play button, then the cylindrical parts are rolling over this conveyor.
What if this green arrow is not appearing here? I'm doing something wrong.
Probably, yeah. Just hang up. I will move around later on. If you have problems, then we can go through. But let's try to set up the layout. So next conveyor I also have with me here. Then okay, I just bring it to little bit closer, and let's work on the top view of it in a way so that I can place it. So this is with some space. So in between we can put the robot. Direction, actually that direction of the conveyor also. So you see the arrows, it's from what right to left, left to right, whatever, but yeah, it should be similar as the feeder also, so that you can connect it, otherwise it will not connect. Anyway, so other one I put it a little bit with the distance, and then I move to, let's say, go to find out the robot controller. So PM transport controller, and here I would like to take it robot transport controller. This is the component that let the robot move. So this I will just I'm placing it in between two conveyors. So it's a robot transport controller. Again, you can find it here in PM transport controller, e-catalog models by type. Then let's have the robot. So robots, visual components, generic articulated robot. Now robot is just a dummy right now, but to let him work, we need to put it at top of this controller. So I bring it closer again, you see, and just plug in or snap plug at the top of, green arrows appear, just drop it here and release. It is connected or not, then you select this controller and try to move the controller. If it is connected, then it means that robot arm moves together. So robot we have, now we can find out something which is called machines. So we need some machining process we are doing, machine tending. So models by type, machines, visual components, and let's have this parametric 5-axis. Lathe machine. So and let's bring it a bit closer to, or place it in a way that it's a bit closer to the, not really inside, but a bit close to the robot. So if I play the simulation, and I can increase the speed also from this simulation control. So yeah, just we need now connection. So the cylindrical parts are rolling over it, nothing is happening. At least we set up the layout. Now we need to do this connection, and for that purpose, without programming, we can do it. There are some kind of flow components which we can find PM flow component. Now we go to PM flow components, and then there are this kind of components, or let's say the tags, round shape. We can drag it from conveyor process into a 3D world and put it at the end of, let's say, first conveyor, or at one end here. So this is the input for the robot to pick it up from conveyor. And then there is another one which is called two conveyor process. So this little bit in greenish color, and that I will put it to the second conveyor at the start, and then again with the left mouse button and just plug in into onto the next conveyor. Here is the robot after machining place the part. So pick from conveyor and then put it the two conveyor process component. Now we can start doing connections or define the flow. So far we working in the home tab. For that, to do some actions or define the process, we go to the process tab at the top, and then select, let's say, product. So it's good that VC cylinder is there. It means that the product is defined, which is good thing. We don't need to do anything here. Then we go to the process tab. In the process tab, if you click it, you see this. Okay, I'm closing this output window, and we don't need it. So you see here we have now some kind of tags or balloons popped up. So these are the processes well all defined. So from conveyor, then we have machining process, and then we have two conveyor. So it means like the pick, then machining process, and the place. So these are the processes defined. We just need to connect them. So I go to the flow, I need to define the flow. In the flow, I'm here, and this is the flow steps window also appearing, which is good, so that we can define the flow. We can do it with our mouse. So I just, my cursor is here. I click over here, and then go to parametric 5-axis lathe and click over here. And from here to here is so easy to connect it. Okay, but since then here to this one. But you see the flow steps are not appearing here, so which is the problem. And what we can do it with this plus sign, we can select it from conveyor, parametric to conveyor. There is another way to do with the mouse also, which we can next time can see it, but this is one way to define. So you just need to connect the flow and describe the flow in the flow step. If it is empty, then simulation will not work. Now if I press the simulation play button, then you see the parts are coming and they start moving. But robot is not working right now, so they are like flying or interpolating, but it's process is happening. So we need to implement this robot, so let the robot work. For that purpose, I just click on this arrow. There are the implementer here. If I click over here and also select the robot from here, both are yellow, right click and change to the transport controller. For this one also click it or change it, otherwise in the properties also you can have this robot transport controller. Just make it selected so that it becomes now the implementer here is the robot. Now we play the simulation and again and see if the robot is capable to do it. So it's taking it, there is some simulation going on for the machining time, let's say 10 seconds, and it's putting outside. So this is how simple it is to create this kind of simulation in the visual components. I hope you manage it. If you not, then I can try to help you here. Yeah.